Hello guys, welcome back to a new video. In this video we're looking into the Graham's law of diffusion. This is one of the most important topics in the chemistry and in physics as well. In the previous video we have discussed uh, about the effusion and diffusion. What are they? If you haven't checked that video, do check that out because that is quite interesting and important as well. I did made the concepts clear with the help of diagrams and it went amazing. Now let's move it for the today's topic, that is the Graham's law of diffusion. Uh, Now this law, of course, this law, the name states that this is Graham's law. There was a scientist named Graham's law. There was a scientist named Graham. He gave this law, and that was about law relating to the diffusion. He explained the diffusion, and he presented a law according to it. Now what he stated, I'm not writing the complete sentence. Do write it if you want. He stated that at constant temperature and pressure, I'm repeating again, at a constant temperature and pressure, the rate of diffusion and effusion of a gas is inversely proportional to the square root of its density and molar mass. Now I'm writing the formula, and from that formula you'll get to know uh, what the statement says. I said that the rate of diffusion, I'm writing that with R, is inversely proportional. That means inversely proportional. This is just the definition in the mathematical form. The rate of diffusion is inversely proportional to the square root. Sorry, uh, the rate of diffusion is inversely proportional to the root of uh, molar mass, uh, to the square root of its density and the molar mass. Molar mass, I can write it over 1 m. And secondly, rate of diffusion is inversely proportional to the density, square root of density, the root of density. Now this is a scene, and for suppose if you got uh, two gases, you want to compare the rate of diffusion, you will say like m1 r2 over md r2 over, sorry, this could be r1 as well. These, you can use any method that depends on the data given in the problem. uh, Here R2 you have, and that is inversely proportional to 1 over M2, right? And over here you have R2, and that is inversely proportional to 1 over D2. This is how it works, and uh, we have got a combined formula for the both, that is like R1 upon R2 is equal to M1, sorry, the M2. There is an inverse relation right here, it will go up and this one will go down over here. Okay, so M2 upon radical M1, this is the case, and this is very important formula. We'll be doing problems related to it in our upcoming videos shortly. uh, there is a special video for the problems related to this topic, and I do hope that you've got the concept. Like, this is a law, and this will tell you the, for suppose, okay, so we can also write this one as R1. I don't know why my R goes like that. uh, R1 upon R2 is equal to radical D2, D for density, upon D1. This shows the rate of diffusion. For this you need to watch the problems video. We'll be explaining that into that one. I do hope that you've got the concept. If you did, do like the video. Meet you guys in the next video. Till that, goodbye.